Good morning, children. Most of you had sent the homework on time. I really appreciate it. Please continue the same way and try to be on time. Some of you who had sent it late, I had sent you a message saying to try to be on time. So I hope and expect that you will show the same cooperation throughout. Okay. So that day we did till this types of speed and types of velocity. Okay. So there are two main things that we saw: uniform speed and uniform velocity. So what is uniform speed? Whenever a body covers equal distance in equal intervals of time. I told you, suppose 5 kilometer, a body covered in say 10 minutes. The next 5 kilometer, again it took 10 minutes to finish, and then another 5 kilometer, again 10 minutes. Now this kind of motion is called uniform speed. Okay, so now this body might take a turn. It was going in this direction, now it starts going in this direction, again covering 5 kilometer in 10 minutes, 5 kilometer, 10 minutes. So as you know, in speed we are not worried about the direction. It can go in any direction as long as it covers equal distance in equal intervals of time. You call it moving with uniform speed, even though its direction is changing from this to this. But when I say uniform speed, it is uniform velocity, it is very important that the body is in a particular direction. Now this kind of motion, a body going towards east then coming towards south, this is not moving with uniform velocity. It is moving with uniform speed but not with uniform velocity. Okay, because its direction is changing. When I say uniform velocity, it means a body should cover equal distance in equal intervals of time, but only in a specified direction. It should not change its direction. Okay, now some bodies will have uniform speed but will not have a uniform velocity. That looks so odd. Even this example, this body is covering equal distance in equal intervals of time, so it is of course uniform, but I can say it is uniform speed, but it is not traveling with uniform velocity because direction is changing. Okay, this is one example. This is another best example for this. Now, so let us take, this is example 1 and example 2, a body moving in a circular path. Okay, a body moving in a circular path. Okay, it's going like this, like this, like this. It's moving in a circular path and it's covering equal distance in equal intervals of time. Suppose this was say 5 meter, it covered in 5 seconds. This is another 5 meter in 5 seconds, another 5 meter, 5 seconds, 5 meter, 5 seconds, 5 seconds. So this body is moving with uniform speed because it is covering equal distance in equal intervals of time. So it is moving with uniform speed, but not uniform velocity. Okay, not uniform velocity. So not uniform can also be said non-uniform velocity. Okay, the other way you can say. So it is moving with uniform speed but non-uniform velocity. Uniform velocity. There's another word that's called variable velocity. Variable velocity. So I can use any one of these words. Uniform speed but non-uniform velocity or variable velocity. Okay, so this is one example that keeps coming very often. So example of a body moving with uniform speed but variable velocity. So this question comes very often. Give an example of a body moving with uniform speed but variable velocity. So this could be the best example. Now, why do we say it is variable velocity? Because its direction is changing continuously. Now, how do we find the direction in a circular path? At this point, if I want to know the direction, I should draw a tangent. So this is the direction at this point. At this point, the direction is like this. At this point, the tangent will be like this. So can you see the direction changing? The direction is changing continuously. Therefore, it is non-uniform velocity or variable velocity. So the answer will be, okay, start from here. The motion of a body in a circular path, even with uniform speed, is with variable velocity. It is moving with uniform speed, but it is variable velocity because in a circular path, direction of motion of the body continuously changes with time. Direction of motion continuously changes with time. In fact, its velocity changes at a uniform. Okay, you can just write like this. This much is enough. Okay. Speed is uniform because it's covering equal distance in equal intervals of time. But velocity is not uniform because its direction is continuously changing. Okay. So, then you have difference between speed and velocity. So, the first 2 points are very important. You can just remember them. That's enough. Okay. Then these 2 examples also can come in reasoning question. Give an example for a body for which average velocity is 0, average speed is not 0. Average velocity is 0, but average speed is not 0. Okay, if a body starts its motion from a point and comes back to the same point. See, displacement is 0, naturally velocity will also be 0. So that is the same. A body starts and comes back to the same point. Displacement is 0, naturally velocity will also be 0. Distance is not 0, so speed is also not 0. Same, another possibility is if a body moving in a circular path covers equal distance in equal intervals of time, speed is uniform, but due to continuous change in direction, its velocity is variable. The same like this example. Okay, so speed and velocity, we had quite a lot, but the main thing is these reasoning questions. Okay, this one and this one. This is what comes. Apart from that, the formula for average speed and average velocity. Average with this you will be using in numericals very often. Average speed is total distance traveled upon total time. Average velocity will be total displacement upon total time. Okay, these 2 formulas are to be remembered because you will be using in numericals. Then comes the last term, acceleration and retardation. So far we saw distance displacement, then we saw speed velocity. Now we have acceleration and retardation. Okay, so you know what is acceleration? So in a car, suppose when your father is driving a car, he has 2 controls, right, in his leg. One is if he presses accelerator, speed will increase. Okay, and then if he presses the brake, speed will decrease. Now basically acceleration means increasing speed. Okay, increase in speed with respect to a particular time. Okay, suppose your car was moving at a speed say 30 km per hour, and then your father pressed the accelerator for 5 seconds. Okay, so its accelerator was pressed for 5 seconds. So slowly your speed increased and it reached 60 km per hour. Okay, speed has increased from 30 km per hour to 60 km per hour because this accelerator was pressed for 5 seconds. This is called acceleration. Increase in speed during a particular time interval. Now, how do you calculate the acceleration? Formula is change in velocity upon time. Change in velocity upon time. So, 60 minus 30 upon 5. That is 30 by 5. That is 6 kilometer per hour square in this case. So, its SI unit will be meter per second. Velocity, you know, is meter per second. This is not SI unit, children. So, leave it. This is just for example. But if I talk about SI unit, velocity is meter per second, time is a second, so meter per second square. So unit of acceleration is meter per second square, or ms minus 2. It can be written like this also. Instead of this division sign, I put a multiplication sign and I bring it to the numerator, so s becomes minus 2. Unit for velocity, speed, meter per second, or ms minus 1. Meter per second or ms minus 1. Unit of acceleration, meter per second square, or ms minus 2. So please don't confuse these two formulas, these two units. Often children confuse these two. Try to be clear with that. Okay. Now, definition also is basically the formula is the definition. Acceleration is rate of change of velocity with time. Acceleration is rate of change of velocity with time. So formula is this, definition is also this. Then there is something called retardation. Retardation is opposite to acceleration. So when your father pressed the accelerator, speed changed from 30 to 60. Now, instead of pressing accelerator, suppose if we press the brakes, the speed would have changed from 30 km per hour to 10 km per hour, or it would have even come to 0 speed, 0 km per hour, come to rest. Okay. So, in this case, speed decreased during a particular interval. Brakes were pressed for 5 seconds, so speed decreased from 30 to 10 km per hour. This is called retardation. So the definition of retardation is, it is negative acceleration. Okay. So, or the other way is, retardation is decrease in velocity per second. This is increase in velocity per second. Retardation is decrease in velocity per second. Okay. So then unit, meter per second square, or ms minus 2. Then relation for acceleration. Now, so we know the formula of acceleration as change in velocity upon time. Change in velocity upon time. Usually so change in velocity means body it was moving with one velocity. Okay, let's take the accelerator thing only. So it was moving with one velocity, and when accelerator was pressed, its velocity changed to another. So this velocity is called initial velocity. Initial velocity. And this velocity is called final velocity. Did you understand, children? So the velocity with which it was moving initially, that's called initial velocity. Then the velocity to which it was increased after pressing accelerator is called final velocity. Usually initial velocity is represented by u, small u. Okay, and final velocity, small v. So this is the same in physics. Even in 11th and 12th, you'll be using the same symbol. Initial velocity is small u, final velocity is small v. So what is change in velocity? 60 minus 30, v minus u. Okay. So change in velocity, okay, in terms of, generally if I have to write, I have to write v minus u, final velocity minus initial velocity upon time. A is equal to, now cross multiply it, a into t is equal to v minus u. Now bring this minus u this side. So v alone keep this side. So minus u will become plus u. So u plus at, or v is equal to u plus at. Now this is called relationship between u, v, a and t. Okay. This is like an equation you have to remember. So we'll be using in the numericals. They will give you any three and ask you the fourth term. There are four terms in this, right? Initial velocity, final velocity, acceleration, time. Out of this four, they'll give you three and ask the fourth term. And use this equation to find. So that is what is given here. Okay. V is equal to u plus at. That's the relation for acceleration. Then they have given some examples. One more conclusion you should remember. Now, usually retardation, okay, even the case I told you the speed changed from say 30 kilometer per hour, brakes were applied and speed became 0 kilometer per hour in 5 seconds. Okay, so now what is the change in velocity in this case? Change in velocity upon time. So change in velocity is 0 minus final minus initial. So 0 minus 30 upon 5. That will be minus 30 by 5 or minus 6 okay, meter per second square or whatever it is. So if you have a minus here, that means it is not acceleration, that is retardation. Okay, acceleration I'm getting in negative means the body is undergoing retardation. Whenever your acceleration, whenever the answer comes in negative, that means the body is undergoing retardation. So that is what is given here. It may be mentioned here that acceleration of a body does not determine its direction, while velocity determines the direction. The positive or negative sign of acceleration tells us whether velocity is increasing or decreasing, whereas positive or negative sign of velocity tells its direction. So you can leave this all for now. So that is all for the theory portion. Now we have some numericals based on average speed, average velocity, and then based on this equation and all that. Okay, so I'll be doing some example questions and exercise I'll be giving as homework. Now before that, so you have written these two answers. I want you to take this as third question. Question number 17, please strike it out and write it as 3. Give an example of motion of a body moving with constant speed but variable velocity. Draw a diagram to represent such a motion. So which one? This one. Till this is the diagram. This is the answer. This is the diagram. That's your third question in theory. Fourth theory question is, give an example of motion in which average speed is not 0 but average velocity is 0. This one, you can give this example. This example. Okay. And then as fifth question, I want you to write this. Note it down. Give the formulas for speed, average speed, velocity, average velocity, and acceleration. Speed, you know, distance upon time. Average speed, total distance upon total time. Velocity, displacement upon time. Average velocity, total displacement upon total time. Acceleration, change in velocity upon time. Okay, and these questions, answers are given. Just read it. Just read it. This is also just read. I'm not giving us homework because answers are already given, but I want you to go through these questions, these things. The lot of logical questions are involved in this. So 2 you have done, 3, 4 and 5 you have to do now. Plus we'll be doing some numericals quickly. So the first one we are going to do is this one. A body rises vertically up to a height of 125 meter in 5 seconds and then comes back to the point of projection. So you're throwing a body up. Okay. So it travels a height of 125 meter in 5 seconds and then it comes back. Okay, you threw it up, say a ball or something, you threw it up, it went here and came to your hand back. So what you have to find? Total distance. What is the distance travel? 125 meter up, 125 meter down. So that will be 125 plus 125, 250 meter. Then they've asked you displacement. What will be the displacement? 0. Why? It starts at a point and the ball is coming back to the same point. So it's like 125 minus 125. So you'll have 0. Average speed. Average speed will be, formula is total distance upon total time. So your total distance is 250 and total time is 5 seconds for going up. So 5 seconds for coming down. So 5 plus 5, 10 seconds. So this will get 25 meter per second is my average speed. What about average velocity? I think they've asked you to find average velocity also. So average velocity is total displacement upon total time. Displacement is 0, time is 10 seconds, but still numerator is 0, so answer will also be 0. Did you get it, children? So distance 250, displacement 0. Okay, so this is how you have to calculate this. The next sum that we are going to do is example question number 7. Example number 7. A car travels a distance of 50 km with a velocity 25 km per hour. Okay. So, and then 60 km with a velocity 20 km per hour. So, it covered a distance of 50 km, velocity 25 km per hour. And then it covered a distance of 60 km with a velocity of 20 km per hour. It's slowed down. Okay. First it was going at 25 km per hour. Then it has slowed down to this one. And the question is, but in the same direction. Calculate total time of journey, average velocity of the car. So you'll find this time separately and this time separately, add both. So we know that velocity is distance upon time. So time will be distance upon velocity. So distance is 50, velocity is 25. So it is 2 hours. It's not second, it is an hour. Same way here time will be distance upon velocity, that is 6 by 2, 3 hours. So we covered 50 km in 2 hours, 60 km in 3 hours. Now the question is, what is the total time of journey? Total time will be 2 plus 3, that is 5 hours. Then average velocity. Average velocity will be displacement upon time, total displacement upon total time. Now because it is going in a particular direction, in the same direction, distance and displacement will be same. So this total distance is 50 plus 60, that is 110, and displacement will also be 110 because it is going in the same direction. So 110 upon total time is 5. So it will be 22 kilometer per hour. 22 kilometer per hour will be the speed, average velocity. Is it clear, children? Now, you have to pay attention in one thing here. Now, sometimes here they have given distance in kilometer and speed in velocity in kilometer per hour. That is fine. Sometimes they will give this in kilometer and this will be given in meter per second. Okay, then you have to convert this into meter or this into meter per second, any one thing. Okay, so make sure if this is in kilometer per hour, this should be in kilometer. If this was in meter, it has to be converted. Or if this was in kilometer, this was in meter per second, then also you have to convert. So, and the last type of question that we're going to solve is question number 8. Numerical number 8. This is very simple. Velocity of a body increases at a constant rate from 20 meter per second to 50 meter per second in 10 seconds. So what is 20 meter per second? Initial velocity, that is u, 20 meter per second. What is 50 meter second? Final velocity is 50 meter per second. And time 10 seconds. And you have to find what? Acceleration. Acceleration is v minus u by t. 50 minus 20 upon 10, 30 by 10, or 3 meter per second square. 3 meter per second square. That is the acceleration. Is it clear, children? So, you'll have the numericals based on this formulas only. Average speed, average velocity, or simply time is distance upon velocity and all that. Okay. Now, the homework numericals are numerical number 5, numerical number 6, 7, 9. Okay. 7 and 9. 5, 6, 7, 9. So here it says a body starts from rest. If a body is starting from rest, means its initial velocity is 0. So in this case, its initial velocity, if it is starting from rest, that means its u is 0 and occurs a velocity of 10 meter per second. So v is 10 meter per second and time is 2 seconds. Okay, children, u is 0 if it is starting from rest. Keep this in mind. So, you will do this 4 as homework, 5, 6, 7 and 9. And the same procedure, finish, okay, these 3 theory questions and these 4 numericals and WhatsApp to me by today night. Thank you so much.